good afternoon. I'm glad to be here. To be honest, it's my first time on a stage in a theater. Or is this AGVs theater? It doesn't matter. For my first time, I'm stay on stage. So I welcome also my colleague and my friend from VW, Dirk Thieme. Probably you introduce yourself.
Okay, yeah, hello from my side as well. My name is Dirk Thieme. I work at VW for more than 20 years in different positions and responsibilities on IT side and production planning side as well. And since 1st April 2020, I'm responsible for the division New Mobility and Innovation at VW Saxony. And so from my point of view, I have the honor to work on the smallest but the most beautiful location of VW, the transparent factory in Dresden. And in addition, I'm also founding member and member of the management board of the Industrial Digital Twin Association. Who's know the Industrial Digital Twin Association? Nobody? Okay, the IDTA is a co-innovation community with the aim to promote a worldwide integration of a standardized digital twin for the entire industry. And that's the reason why I'm also a founding member of the IDTA. So at first I will start with a short overview of the challenges we are facing. So I think these challenges would be well known, and at first we have to improve our productivity, efficiency and flexibility by using or leverage digital solution. This challenge comes in order to establish uniform standards, the consistent use of data, ensuring data security and cybersecurity. And we have also to tackle the growing demands of the circular economy, and we have also to reduce our product carbon footprints. But last not least, to coordinate all these joint activities across our departments, locations and regions is an important one. And so VW has made a really important decision in 2020 to be a founding member of the IDTA and apply the asset administration shell for driving forward the IT and digitization roadmap for a smart connected factory and in order to realize Industry 4.0. And MHP is our integration partner for the asset administration shell. And so I would like to hand over to Stefan to start your presentation.
Okay, thank you. I guess we have a business relationship for more than 10 years, Dirk, where we work together in the same area with manufacturing, digitalization and all those stuff. So then let's start with the topic here. I think I have to apologize for the title. We said, well, apply digital twins to make the old ground field ready for Industry 4.0. That's a little misleading because in order to keep you curious and also interested, so we hide something. And what we hide is probably more interesting thing. That's the use case we had for the AGV fleet and the energy model and stuff like that. And we use analytics to understand how the AGV movement can be optimized, and also the energy consumption of the AGVs can be, of course, optimized and improved. So that's what I have concealed in the title. Nevertheless, we start with a simple fact that we have, unfortunately, a lot of brownfield devices. And in this sense, it's almost in digitalization. I always say we have two messages, a good one and a bad one. The good one is we have from Industry 4.0 much nice concepts that we can employ. We need a seamless device integration, horizontal and vertical integration of devices. We have all those topics with digital twins, using some AI in all our shop floor systems. But if we go and try to comprehensively use the nice techniques in our shop floor, we get maybe very soon a little bit depressed because of the old devices we see in the shop floor. And that's the brownfield case, because the brownfield simply isn't able to get connected to a network. So this means we can also not simply get any data from the brownfield and look at AI, how AI needs data, and it has to rely on the correct data, but how we want to get the data from the brownfield device in an industrial way. Maybe you have someone who writes by paper what the device is doing, but at the end this quite pointless and will not lead to success. Therefore, we have to think about how we can lift up our old brownfield and make them ready for the future. And actually, there's a way to do this. And next slide, please. We can, of course, bring them to the next stage. Simply that we look for a way how we can mobilize the static data structure of those brownfield devices. You probably all know what a PLC is. A PLC is at the end nothing more as a long array of different data sources that we can read. Unfortunately, that's a fixed structure. There's nothing we can change during the process. We always have to rely on the same structure. And if you think about we need a new data, for instance, for a currency or what else, then we have to change the PLC structure, and this is quite costly. Therefore, everyone tries to avoid this, and at the end lives with this fixed structure of a PLC, which is not very good. But at the end, with digital twins, we can make this old brownfield more alive. So we can, first, we can make them living in a, let's say, a very flexible platform, because we can do some changes also during the operating work of the PLC or the brownfield device. We can have it measurable, and measurable means we get data, and the data we need, and we get all the data as a comprehensive data view figure on those brownfield devices, because single data, most cases, tell us not that much, because we need the relationships between all those data in order to understand the data. And this leads me to the next aspect, to adaptability, because if we adapt just one single data, we may overlook the rest of the story we need to take in account in order to get a consistent data view after our adaptations. And this most cases missing. Next, please. So, what's this? I think this is something what go further. Apologize for this one. This is
next slide.
Next slide.
Okay, sorry.
Because not from interest, so we already passed this. The question is how we can really make this digital twins, this old brownfield devices, as I said, adaptable, measurable, and flexible. And this may work with the use of so-called digital twins, and you see a kind of an architecture here. We have all those old stuff in the shop floor. There's all the old devices we have, and we have the chance with digital twin to do some augmentation on these old devices. So this means we model the behavior of the devices, and that way we get all the data we need in the model, and we populate all the models of the devices on a single layer. You know, you must think this is a layer on this above the single devices you see on the shop floor, top down, and over those level we can bring on northbound all the application we need, and the applications then are able to consume the data they need for analytics and other things. But they get a complete figure of the data from each device via the model from the digital twin. So the digital twin is something like a data provider, a data collector, and also a data cleanser in order to provide the correct data in or provide the data in an affordable way. Next, please. I think this again not correct. Please go further.
Okay.
So, what means augmentation? This is actually an example here. Where you see what we have done also for VW Sachsen. We have in the middle the so-called asset administration shell, and the asset administration shell is a representation of a digital twin. And the good thing on an administration shell is that it's a standardized structure we can use in order to model our shop floor devices. And what you see here in the middle is it's just an administration shell. An administration shell has different submodels in it, but at the end you can think of an administration shell as just a simple structure. There's nothing else. There's nothing in. There's just a structure. There's nothing about anything. It's just a structure we have in order to communicate it to communicate to other layers, like for instance applications. But the important thing are the submodels, because the submodels describe the semantic of an administration shell and describe what the digital twin is doing. They describe what data they get, what data they need for instance, for analytics and stuff like that. So you see here, if you look at an administration shell, they have these different submodels. And I guess the submodel below is the one I think a little bit bigger. The submodel describes also the structure of the assets. For instance, in this case, the AGV and the battery we use, and this gives us a chance to have flexibility. Why we will have flexibility with this model? If we get bored with some of the models, we just throw it away and bring a new one in. So, for instance, you can think of a simple robot, and the robot, for instance, has a gripper just to put some pieces. And in the administration shell, we can describe the properties of this gripper in order to see what the gripper is doing. And if we're going to change it, for instance, if you use or if you want to do welding, then we throw the gripper model away and bring a model for the welding gun in, and the welding gun then does the same with the gripper model, but we just change it. Yeah, I mean, we can change it within a running process. This means we gain flexibility, and there's also something about efficiency. Most cases, in the old days, if we change something in the shop floor or on the shop floor device, we need a human, let's say an engineer, going down to the machine and do physically the changes. So, and what this engineer has to do, he has to read carefully some paper and then do the changes manual in the shop floor. This is not anymore the case, because we can just play around with the models we have in the digital twin, and so we can reorganize our shop floor production in reality, or not only on demand. It's the same way with auto colleague. Because we can do it near time, let's say. Next one is plug to produce. It's the same thing. We just can say we bring a new model in and do a new process.
So okay, let's take over, Stefan. So it was a little bit a deep tech part from Stefan. So it's really important. There's a lot of things to do in the background. So The IDTA is working on standardized submodel templates for a lot of assets you can use. And so the real benefit of digital twins is you can match the asset properties with the real world behavior. And so you can continuously improve the asset on its usage, so on its real usage. This is a really big benefit from my point of view to use digital twins, and you use also standardized digital twins. So, and for our use case, so we are running a little bit out of time. So I would like to. So this is our slide deck. I see. Okay. So I will talk a little bit about our special use case in Dresden. So we have optimized, or we have taken over the approach from a charging management from the electric cars to an entire AGV fleet. So and the normal design of AGVs today is meets to transportation requirements. However, to totally optimize the total cost of ownership, you need more than the aspect of transportation requirements. So it's important you use also and consider measurements or status data like energy consumption, CO2 emissions, or the battery lifespan. Or you have also to use operational data like routes, distances, the number of charging points, or the fleet size itself. So, and by leveraging all this comprehensive information, so we expect a potential improvement of 30% in efficiency and cost effectiveness. So, and in this use case, we're using the asset administration shell as a digital twin for the AGVs. So we have submodel templates for AGVs, for batteries, for sensors, or for charging stations. And it comes with a lot of many benefits. So, and one of the key advantages is we can use an AI-based control loop for a dynamic and smart charging of the whole entire fleet. So, and by using artificial intelligence, the charging process can continuously optimized and tailored to the specific needs and conditions. And this leads to effective use of resources and also to a longer battery lifetime. And it's also interesting to see in this use case, we have a potential of 38% to save emissions and energy by our AGV fleet. So thank you very much. And if you have any questions, we can talk now or after this presentation, and thank you for your attention.